All right, number 4, now we're going to be looking at truth tables. They can be a little bit tricky, but once you understand them, they're pretty straightforward. So we could give statements to P and Q or whatever letters we use, but it's not necessary. What you're given here in A is that P is true, and then right below it on the second row or third row, if you want to call it, P is false. This little ampersand, little squiggly line, means to negate or not, give you the opposite truth value. Okay, so if P is true and then we're saying not true, then that means this is going to be false. You're going to give the opposite statement. And then a double negative just goes back to what we started with. So not false, what this is saying, means true. So you're just going to, whenever you see this little ampersand, you're going to negate it or do the opposite truth value. So down here on this column, P is false. So if we're saying not false in this bottom column, that means true. You just follow across. And then this means not true. We're negating this case, so that would be false. So don't think that just because you see a not in front of it means it's going to be false. It depends on what the original statement started out to be. So you're just going to do the opposite here, and then you do the opposite again on the next column. All right, B, we have some compound statements. I'm going to kind of point those out to you. All right, so again, I'm going to start out with P being true. It's going to go across. This is going to be false. All right, now we have the compound. Okay, this V, which you might have seen in the text if you went through the notes, the V is or. Not of, it's or. V means or. This or this. Okay. Whenever you see this or, this compound, you need to know that this statement is only false if both are false. Okay, so if you have a statement containing or, it is only going to be false if both of those statements are false. Okay, so you have two statements at a time. So I might say I will take my kid to get ice cream. So he will get ice cream. I'm just going to put ice cream over here. If we're going to say he cleans his room or he makes all A's. Okay, so he has to clean his room or make all A's. If he doesn't clean his room, but he makes all A's, he will still get ice cream. So it'll be a true statement. However, if he doesn't make all A's, but he cleans his room, we will still get ice cream. If he doesn't clean his room or he doesn't make all A's, then we will not get ice cream. So if both of these are false, that's when we're going to end up being false. Otherwise, they could both be true, or one or both could be true, and it will be a true statement. Okay, so that's when we have or. So right here in this first box, we have P or not P. So we have true or false. That would mean this would be a true statement. Okay, because they both have to be false in order for this statement to be false. That's the main condition you need. If they're not both false whenever you have or, then it's automatically true, no matter what else you see. And then the last one we see is the and. So the upside down B means and, okay, which means both conditions need to be met. So what you need to remember for and, it is only true, main condition, only true if both are true. So I could do the same thing with the ice cream example. Clean your room, make all A's, you get ice cream. If he cleans his room but doesn't make all A's, no ice cream. If he doesn't clean his room and makes all A's, no ice cream. He has to do both, this one and that one. So this statement with the and is only true if both statements are true, looking at two at a time. Okay, so now this last column, we're looking at P and not P. They're not both true, so that means it's automatically false. So I'm giving you one condition. It's true if they're both true. Everything else is false. This one is false only when they're both false. So you got to kind of remember those rules, and then it'll make everything else simple. So here we start out with false. We're going to negate false, which means true. And we're looking at this or this. So if they're not both false with or, then that means automatically true. And then they both have to be true here. So since one of them is not, then that means this statement is going to be false. All right, now we got a part C. It says the statements P and not P blank are logically equivalent because their truth values are the same for every possible truth value of P. So up here, when we had P and then we had the not, both of them were true. We had false, and then we had the not. It is also false. So it just negates the negation or undoes it. Oh, there was another part. Yeah, there's a part D. I didn't see that. Okay, the statements P and not P. So I'm sorry, the P or not P, P and not P. So we're looking at P and then P or right here, these two. These are not equivalent. Their truth values are not the same. They're different. One's true, one's false.